Most Kafka tutorials stops at sending a message. This project goes further. You will build a practical event-driven backend system using Kafka, where 3 Spring Boot projects communicate with each other in a synchronized way. An order service that creates an order, a payment system that reacts to the order events, and the notification system that records everything that happens across the system. This is a Docker Compose file that we have. And by the way, I have architected this project in multi-module system, like it's kind of modularized approach, because I felt like it's gonna be better with this way. So we have those kind of 4 services that we have. We have Postgres, Kafka, and Kafka UI, and the Jaeger. So basically each one of them had its own configuration. I will include this repo in order to view the configuration that I had used, because everything has so many configuration here, especially Kafka. And this is Kafka UI. It will depend, of course, on Kafka's, because that's a UI in order to view what's happening in Kafka. And we have also Jaeger. So I have also 2 libraries here. The core library here is going to be responsible for some data that we have that's common across the systems that we use, which is a notification service, order service, and payment service. So I want to mention we have some kind of exception handling here. I will not walk you through because we're going to be focusing on Kafka. So here I have created a specific configuration for our topics that we have. So for each topic that I have created its name and the number of partitions that we have and the number of replication we have. So if each topic that we have contains like partition of 3 and the replication count is just 1, and this is the name. So those are our topics that we have, and this is also the factory that we are being used. And we're enabling the observation because we want distributed tracing. So the trace IDs that we get from the initial request should be transferred across the other systems in order to have a single trace across multiple systems. And I want also to tell you that we have just a provider, which basically has a helper method, get trace ID. It's going to be simple methods that's going to be help us to get the trace IDs that get distributed. Because we want also to identify what's happening, we're going to be setting it as a response header that we're going to be using in future when you're working with APIs. This is our core library. For the second one, it's simple like Kafka topics. It's going to be the names of our Kafka, and we have simple DTOs for our Kafka events, such as notification created or payment failed. Simple events. Those are simple 2 libraries that we need to use across the other services that we have. Now for our 3 main services here. Let's start with the order service because that's a big one first. So here we have a controller. This controller is responsible for creating order, and we have 2 endpoints that get some data. So what happens here, we have in our service here, when we create an order, we're going to be starting by setting the statement to be pending payment, because the flow is as follows. We're going to be creating an order. Its state is going to be pending. Then we're going to be sending to Kafka a message. We tell him, hey, an order was created, so I want to get a payment for this order. When we send the Kafka message here, then payment service is going to be our consumer here. It's going to be listening to this event, what happened for the order that was created. So it's going to try to make the payment for this order. If the payment succeeded, it's going to be sent a payment success message to the notification through Kafka. And when the payment sent to the Kafka, the new events, the notification is going to be consuming the notification events that it had retrieved from the payment. And not only that, if the payment is succeeded, we need to notify the orders in order to update the order that was pending payment, because now the payment is due. So not only we informed the notification that the payment had been succeeded, but also the order is going to be a consumer to the payment, whether it was success or failure, because if it's going to be success, then we need to mark it as confirmed. If it's going to be failure, then we need to mark it as a failure. And this is what we're going to be doing now. So at the initial phase, we're going to be creating an order with setting it as pending payment, and then we're going to be saving this in our database, and we're creating an order creating event, and we're going to be publish it to be sent to the payment service. So we're going to be publish it how? We're going to be using Kafka template here. Kafka template is going to be sent for this topic, the order created, and the key which we're going to be using is the order ID. And we're using the key here because we want this order to be sent specifically using a specific partition, because we have topics here and each topic has 3 partitions. So Kafka under the hood takes this unique key and make use of consistent hashing. It should hash this order ID and it will be send it using a specific partition. So each time we're gonna be working with this order ID, it should go to the same partition that we use. And third argument is basically or the objects that we're gonna be sending, which is in our case order created event, and we have a set of timeout of 10 seconds. And if things goes fine, we're simply logging just a message. We're logging just a log saying the order is successfully happened. In case of an exception happen, we're gonna be throwing this exception. That's gonna be what happened. So what happens when we publish this here? Let's go to the payment service here. Payment service is very amazing here. We're gonna be using now our consumer here. So we have order consumer created here. This lesson on the orders created. This means that was the topic that we sent to from the order microservice. So we sent it here to this topic and payment listens to this topic. So now we had retrieved a new message and now we need to process it. So what happened in the processing is we're talking if a payment should be success or not. We basically have some kind of hard-coded validation here. So if the payment is less than 5K, then it's gonna be success. If it's more than 5K, it's gonna be a failure. So if we try to send like 3K, it's gonna be success case, and we should be updating it with success state for this payment. And we basically gonna be save this payment entity, and we should notify the order that was created that this order is paid or failed, depending on whether it's success or failure. So if it's gonna be success case, then we're gonna be publish another event. This publish payment success is gonna be responsible for sending the payment success, and when it sends a payment success, we're also gonna be using this event. We're gonna also use the key for our order ID, and this is a topic. So payment success, it should be available in the order consumer. Why? Because it's gonna be listening on the payment success, because we want to mark the orders to be confirmed once the payment is actually success. So what about failure? So in case of failure here, we'll also publishing a payment failed event. This payment event is a different topic. So guess where it is gonna be available? It's also gonna be available in the order payment event consumer in the orders. Why? Because it's going to be responsible for marking the order to be cancelled. We're simply making it to be cancelled and updating the database. So that's basically what happens here when we're having a payment. So what happened for the notification so far? We hadn't really touched the notification flow so far. When an order gets created, or payment success, or payment failure, we have a listener to each one of those. And each one of those handles things on its own. Like it processes each one directly. So now we had retrieved for this order created. This was the initial phase. And then we're going to be creating and publish notification. What happens here, we're basically setting some kind of value. We're saving into the database and we're logging some kind of stuff. And then we'll publish a notification created. This notification created is basically sending to a topic which is called notification created. We're using the same order ID. And this notification ID is not being listened to anywhere. And this is basically the endpoint to our flow of producing a message, because we didn't really introduce anything else for this notification created. We can have a consumer that consumes this topic and act on behalf of this topic. But so far we hadn't really implemented. So that's basically how things happen when we're working with Kafka. But there's something that I want to mention. If you hadn't noticed, we're using order created here. And we're also using the order created here. So basically we have the same topic here into different microservices. This may be like a bit of confusing to you, because shouldn't the message get processed once and not multiple times? This is where it comes with the group ID. So this is happening when we're consuming in the order created consumer in the payment. So in the payment service, this is a group ID. This is a different group ID than this one, which is notification service. So now I want to place them just next to each other so we can visualize what's happening. Okay, so now we have a group ID of payment service and we have a group ID of notification service. Since both of them are two different groups, this is why it can be handled in a different way, different consumers, because they are not the same group. This is different than this one. This is why it handled into two different ways. That's basically how we work with Kafka regarding producing and consuming stuff. And I am going to be showing you a demo in order to try it out, make sure that everything works as expected. Okay, so everything is created and healthy. the order service has been started correctly. The payment service had also been started. And now the Tomcat also the notification service had also started. So now everything has been started. Now let's try to do some kind of work. Okay, so here I'm gonna be creating a successful order. I'm gonna be get all order first because I want to make sure that everything is empty. So now we don't really have anything in our database. I'm gonna be creating a successful order, and it's gonna be 201 created. And if we check the database, it's gonna be checking for the order. It's gonna be created with 3K, and the status, if you check, it's gonna be confirmed. This means it's gonna be available in the notification, and it's also gonna be available in the payment. And in the payment, it should be success, and this is actually correct. So far, we hadn't really seen Kafka. Let's view Kafka now. Okay, this is Kafka. We have our single broker here. We have the topics that we have, and we have the consumers available here. So first, we need to make sure the order was created. In the messages here, you will find out this message was the one that we had used. And if you also checked the trace ID here, this is the trace ID of the message that we had used initially. We had created through this create successful order. And if you check the payment service, you will find this trace ID available here. Why? Because we are using distributed tracing. The same goes for notification service. So the flow from the message happened to have the same trace ID because we're using distributed tracing. And if you notice here, we have like received payment success event data, which comes from the consuming part from our order event consumer here, which happened to be this part. So this means basically the order was created, sent to the payment service here, which is basically received order created, and then we're going to be publish this payment success, which was retrieved again here, which was processed successfully here. That's basically for the successful flow. Let's try the failed one. If we tried the failure here, you will find out that we had created another order here, but we also received payment failed event. And this payment failed event happened because in the payment service, when it tried to the payment simulation for this order, it failed due to the fact that it was more than 5K when it was 9K. So basically this was a failure. And if you check the database right now, you will find out the order that with 9K is cancelled because it is failed. And I just want to show you also one part here regarding the distributed tracing. You might be wondering, how does it get this trace ID? When you are working with distributed tracing, we're also sending some headers, and I want to show you some kind of header value. So let's get into any message that we have. We have some kind of key values and headers, and this is the body of the message, and I want you to view the headers here. This is something called trace parent. Trace parent consists of this. This is the trace ID, and this is the span, and there are some kind of other metadata that's kind of pointless to me, but they are being used somewhere, I don't know where. So if you check this trace ID and started to search for it here, you will find it to be available. Why? Because this is coming from the trace ID, like passing the trace parent completely in the headers, so it can be unified across the system that this message get passed to. So you will find this trace parent available in the other flow. For example, the order created, if you check the message headers, you will find this to be available as well here. This is also included in distributed tracing. So sometimes you might be wondering what happens. Like, well, I'm going to be using Jaeger in order to analyze what happens. So for example, the order service here, I'm going to just find all traces. We had some kind of orders here, so those are post requests. I want just to, it took like 89 milliseconds, and this is 1.8. Let's check this one. You will find out this is order post API adds orders. So basically this is the request that we had done here. What happened here, it took like 539 milliseconds in order to send this orders.created topic, and under it, it took like what, 392 milliseconds. This is for the notification service, and the notification service took additional 221 to send the notification created. That is for the notification service. And for the payment service here, it took 378 milliseconds, and it took, in order to send the succeeded, 213 milliseconds. And the notification service, the process for this payment that succeeded, it took like 68 milliseconds. This is also a good way in order to understand what on earth is happening and why the time is being taken using Jaeger UI. This is also a good way when you're trying to observe stuff. So I just wanted to mention it out so you can check out. There are also much more information that you can use regarding this part. And this is also Kafka. I believe like there are so many stuff that you can talk to with Kafka, because Kafka shines when you're talking about scalability. This is just like how you can get started with Kafka from producing and consuming point of view. But Kafka has so many points that you can discuss when we're talking especially with scalability. Yeah, hopefully you enjoyed the content so far, and if you want me to make more advanced topic for Kafka or any other topic, feel free to inform me and I will be delivering hopefully a good topic for you guys. Like the video, subscribe, and see you next time.